A box contains apples and pears. An equal number of apples and pears are rotten. 2/3 of all the apples are rotten. 3/4 of all the pears are rotten. What fraction of the total number of pieces of fruit in the box is rotten? All right, several different approaches here. I'll just use the simple one, or at least what I think is simple. So I have two types of apples, right? I've got the good apples, and then I've got the rotten apples, so AG and AR, whatever variable you want to use. So same thing with the pears. I've got the good pear and the rotten pear. And they tell me that 2/3 of all the apples are rotten. So this guy is equal to 2/3 A. And therefore, I don't know if this is needed, but the good apples would represent 1/3 of A. And similarly, they tell me that 3/4 of all the pears are rotten. So 1/4, I guess, are good. So those are my relationships. And they also tell me there's an equal number of apples and pears that are rotten. So that means that AR is equal to PR. Rotten apples equal to rotten pears. And in terms of my A and P notation, that's 2/3 A is equal to 3/4 P. So now I think that's about as far as we can go, right? Based on the information they give us? I think so. Well, we can isolate for P. I mean, that's pretty straightforward. 2/3A, 4/3 is equal to P. So P is, what is this, 8/9? Yeah, 8/9. Okay. All right, now let's figure out the fraction of the total number of pieces of fruit in the box that are rotten. So that basically means they want AR plus PR over A plus P. Okay. Hopefully we'll get everything in one variable. AR is 2/3A. PR is 3/4P. All over A plus P. But P we just figured out was 8/9A. 8/9A. All right, so far so good. Okay, I got it. This here is the same as this, so we can substitute that in. I was wondering how on earth am I supposed to get rid of that P? But that was pretty straightforward based on the information they gave me in the question. This is going to help us. So instead of 3/4P, I just put 2/3A. Okay, got it. All right, so we got A's in terms of everything in terms of A. So this just becomes we can get rid of the A, right? Everything is in terms of A, so that just disappears. So 2/3 plus 2/3 is 4/3. All over, we got to add this fraction here, 17/9. And then invert and multiply 4/3 times 9/17. And that looks like 36/51. 36/51. In lowest terms, 12/17. Yeah. So D is the answer to number 19. In a bin at the Cayley convenience store, there are 200 candies. Of these candies, 90% are black and the rest are gold. After Yehudi eats some of the black candies, 80% of the remaining candies in the bin are black. How many black candies did Yehudi eat? So initially, we've got 200 candies, right? And 90% are black, so that means 180 are black. And the remaining 20 are gold. And then Yehudi eats some of these black candies. We don't know how many. So let's say he eats X. So that means after he eats X, there's 180 minus X candies remaining. And they're saying that represents 80% of the remaining candies. So the remaining candies would be 200 minus X. And that is 80%, which is 0.8. All right? So that's the mathematical equation for this question. Now let's solve this. 180 minus X would be cross multiply. 200 times 0.8 is 160 minus 0.8X. And this will be 20 is equal to, add 1 to both sides, and you get 0.2X. And therefore X is equal to 100. So that means Yehudi ate 100 candies. And therefore number 19, the answer is D. In the diagram, WX, y, and z represent numbers in the intervals indicated. What fraction represents the largest value? Best thing to do, in my opinion, is just assign numbers to w, x, and y. W approximately 0.2, x approximately 0.8, y 1.1, and z probably around 1.7. So now let's look at the answer choices. X over w. X over w, using these numbers, is approximately 4. Next one, y over x, is going to be about 1.375. Choice C, y over w, and that's going to be about 5.5. Next one, z over x, that's going to be about 2.1 maybe. And then finally, z over w, that's going to be about 8.5. So the largest of these clearly is z over w. So that would mean that for number 19, the answer is E. If m, n, and p are positive integers with m plus 1 over n plus 1 over p is 17 over 3, the value of n is. First, let's simplify this expression, and let's see what we get. So, get a common denominator here, p and p. And let's see, that gives me 1 over np plus 1 over p. All right. Invert and multiply, and that just becomes p over np plus 1. And that's 17 over 3. Okay. So far, so good. Now, of course, we have to, again, get a common denominator, np plus 1, np plus 1. And that gives me mnp plus m plus p over np plus 1. And that's 17 over 3. Okay. So normally, you need the number of equations as variables. So if you have 3 variables, you need 3 equations. We don't have 3 equations. We don't even have 2 equations. We have only 1. So obviously, there's going to be some inspection here. First, let's concentrate just on the denominator. 17 over 3 is in lowest terms because those are both prime, I believe. Correct me if I'm wrong. So that means that np plus 1 must be equal to 3. Okay. That means np is equal to 2. Both of them, well, all 3 of them are positive integers. So how can I make n times p equal to 2? Either n is 2 and p is 1, or n is 1 and p is 2. That's the only way. All right, so let's figure out what happens to the numerator for each of those scenarios. First, let's do it for this scenario where n is 2 and p is 1. So we have m n p plus m plus p, and that's equal to 17. So substitute n equals 2. So we have m times 2 times 1 plus m plus 1 is 17. So that's 2m plus m is equal to 16, and therefore 3m is 16, and therefore m is equal to 16 over 3. Well, unfortunately, 16 over 3 is not an integer, so this scenario is no good. Okay, no problem. We got another one, another scenario. Same thing. mnp plus m plus p is 17. Now let's substitute n equals 1 and p equals 2. So that's going to be m times 1 times 2 plus m plus 2 is 17. So that's 2m plus m is equal to 15. And therefore 3m is 15. And therefore m is equal to 5. And there we go. We got integer solutions. M is 5, n is 1, p is 2. What do they want? The value of n. Well, n is 1. So number 18, the answer is C. The ratio of boys to girls at Gauss Public School is 8 to 5. If there are 128 boys at the school, then how many students are there at the school? Well, the ratio of boys to girls is 8x over 5x, like that. And they're saying that the number of boys is 128. 8x is 128. So that means x is equal to 128 divided by 8, which is 16. So how many students are there? Well, total there's 8x boys plus 5x girls. So that's 13x in total. Well, x we just calculated as 16. So plug that in. 13 times 16 is 208. And that is the total number of students. So number 17, the answer is C. 8 unit cubes are used to form a larger 2 by 2 by 2 cube. The 6 faces of this larger cube are then painted red. When the paint is dry, the larger cube is taken apart. What fraction of the total surface area of the unit cubes is red? All right, well, first and foremost, how many faces do we have if we have 8 unit cubes? Well, each of the 8 has 6 faces, so there's 48 faces. Now, when you paint this whole thing red, each unit cube, how many sides will it have red? Well, just take a look at the diagram. Only the sides that you can see will be painted. The inner sides that you can't see will not be painted. So for each of those cubes, 3 sides will be painted. So we got 8 unit cubes. Each one will have 3 sides that are painted red, and therefore a total of 28 will be red. And they want the fraction, so that's 24 over 48, which is, in lowest terms, 1/2. So number 13, the answer is C. The ratio of apples to bananas in a box is 3 to 2. The total number of apples and bananas in the box cannot be equal to. So apples to bananas is 3 to 2. So that means I can say the number of apples is 3x and the number of bananas is 2x. The ratio would still be 3 to 2. So the number of apples plus the number of bananas would be 3x, since A is represented by 3x and B is represented by 2x. And adding that, you get 5x. So obviously, A plus B is some multiple of 5x. Well, all of these are multiples of 5 except this one. So it cannot be equal to that. Number 13, the answer is E. When the radius of a circle is tripled, how are the area and circumference of the circle affected? Well, let's say initially we have a radius of r. Initially, the area is pi r squared, and the circumference is equal to pi times 2 radius. Or you can write this as 2 pi r. Then what they do is they triple the radius, so now it becomes 3r. Well, the area now is pi r squared, but r is 3r this time. So that looks like pi 9r squared. I can write this sort of as 9 pi r squared. Okay, circumference this time is pi times 2r. My r is 3r, correct? So this becomes 6 pi r. So now we have to compare the areas and the circumference. Well, the area looks like it increased by a factor of 9, and the circumference increased by a factor of 3. So which of those answer choices represents that? It's A for number 16. If A and B are two distinct numbers with A plus B over A minus B is equal to 3, then A over B equals A plus B over A minus B is equal to 3. Well, cross multiply and you get A plus B is equal to 3A minus 3B. 2A is equal to 4B if you put everything on either side. And then A over B would be equal to 4 over 2. And of course, 4 over 2 is equal to 2. So number 17, the answer is D. On the number line, points M and N divide LP into 3 equal parts. What is the value of M? Well, first thing to do is figure out the distance from L to P. So it will be 1 over 6 minus 1 over 12. And that, if you get a common denominator, is 1 over 12. So that's the distance from there to there. Now each of these is a third of that. So let's figure that out. So it would be 1/3 times 1 over 12, and that is 1 over 36. So each of these small distances is 1 over 36. So in order to figure out m, it would be m minus a 12th is equal to 1 over 36, right? This subtract L is equal to 1 over 36. So m would therefore be 1 over 36 plus 1 over 12, multiply top and bottom by 3, and you get 1 plus 3 over 36, and that is 4 over 36. And in lowest terms, that would be 1 over 9. So number 18, the answer is 1/9, and that is choice C.